Ion-dipole forces. Before I continue explaining this topic, let's consider first the difference between ion and dipole. Ions are atoms or molecules that have a net charge. Let's consider sodium atom. Sodium atom has 11 protons which are positive and 11 electrons which are negative. This is not an ion because protons which are positive and electrons which are negative is equal to 0 and there is no net charge. In like manner, chlorine atom has 17 positive protons and 17 negative electrons. This is still equal to 0. That means there is no net charge. Therefore, this is not an ion. What will happen when you allow sodium atom to interact with chlorine atom? Sodium atom will donate one of its electron to chlorine atom, and chlorine atom will accept one electron coming from sodium atom. There is now a change in the number of their electrons. For sodium, it has still 11 protons, but it lacks one electron. So it has now 10 electrons. For chlorine, the number of electrons was increased to 18. Therefore, there is now what we call a net charge. Sodium gain positive ion and chlorine gain negative ion. This is now what we call an ion. Sodium, which is positive, is it has what we call cation ion. Cation or cation. And chlorine is what we call anion or an ion. Now, it is easy to remember which is positive and which is negative. In sodium, you have this positive T here, plus sign, and in chlorine, you have this N. So, we have the sodium positive and chlorine negative. How about dipole? What is a dipole? Well, generally speaking, when we're talking about dipoles, we're talking about something where the charge is separated. We have here the slightly positive and we have here the slightly negative end. There is a separation between their charges on one particular atom. The partial negative end and we have the partially positive end. You can see that there are more electrons found on partially negative end, whereas less electrons found on partially positive end, because we know that electrons have negative charges. Now let's go back to our topic, ion-dipole interaction. We have now differentiated what is ion and what is dipole. Again, let's have a review. For sodium, it has now a positive ion, and for chlorine, it has a negative ion. What happens if you mix salt or sodium chloride into the water? Observe carefully what happened to sodium and what happened to chlorine ion when you mix it with water. These ions of sodium and chlorine will dissociate. The positive charge sodium ion is attracted to negatively and oxygen of water molecules. And also, the sodium ion is surrounded by oxygen, the negatively and of water molecules. Similarly, chlorine having the negative ion is attracted to hydrogen. Because hydrogen is the positively end of water molecules. Positively, sodium ion is surrounded now by negatively end oxygen of water molecules. On the other side, negatively chlorine ion is surrounded by positively end of hydrogen of water molecules. Since sodium ion and chlorine ion are ions being formed through ionic band, water molecules also which are formed through covalent band and formed and considered as polar molecules, it is also a dipole. The intermolecular forces that has to do with this interaction is now what we call the ion-dipole combination. This is the reason why salt can be easily dissolved in liquid water. To summarize, ion-dipole forces are stronger than dipole-dipole interactions because the charge of any ion is much greater than the charge of a dipole. The strength of the ion-dipole force is proportionate to ion charge. The oxygen atom in the water molecule has a slight negative charge and is attracted to the positive sodium ion. In like manner, the hydrogen atom in the water molecule has a slight positive charge and is attracted to the negative chlorine ion. Their combined interaction create the ion-dipole forces.